All right, so 5.6, we're finding rational zeros. So we're kind of taking what we learned using synthetic division, and we're going to apply that now. So we're going to find all of the rational zeros. The first thing is the rational zero theorem. I don't want you to know a whole lot from that, other than you can, if you don't have your calculator, it is possible to calculate all of the possible zeros. So anytime that it says list out the possible rational zeros, you are listing out the all of the factors of the constant term, which in number 1 would be your 20. It's always your last term. In the example, it's negative 105. And then you are dividing that by all of the factors of your first term. So in this case, 64. In number 1, it would be 1. So what we do first is we list out all of the factors of the constant. In this case, we have 20. So the factors of 20 are plus and minus 1 and plus and minus 20. 1 times 20. 2 times 10, so plus or minus 2, plus or minus 10. And the last one is 4 and 5, so plus or minus 4, kind of running out of room, plus or minus 5. Then I list out all of the factors of my leading coefficient. And so my leading coefficient is 1, so all you have is plus or minus 1. And so to find your possible zeros, you take every single combination of constant over leading coefficient. So all of the factors of the constants are going to divide by all of the factors of the leading coefficient. So plus or minus 1 over plus or minus 1, plus or minus 2 over plus or minus 1, plus or minus 4 over plus or minus 1. So I'm connecting every single combination of all of them. Conveniently, the leading coefficient is just 1, so I'm literally just going to write out all of the factors again. 1, 2, 4, 5, 10, 20. The only difference is, so I'm going to change, I want you to change this 2 to be a 2x cubed. So if your leading coefficient isn't 1, my constant factors are still the same. So I'm going to list them all out again. I have plus or minus 1, 2, 4, 5, 10, and 20. Then my leading coefficient, all of my factors of that would be 1 and 2. So 1 times 2 is my leading coefficient. So what I'm going to do is I'm going to combine, so it's like I'm connecting the dots. I'm going to say that all of my possible zeros are either plus or minus 1, so I'm going to rewrite all of my constants because plus or minus 1 over plus or minus 1 stays the same. And then I'm going to also put all of them over 2. So I'm going to say possible zeros include, I'm going to list out all of them again because these are all like over 1. And then I'm also going to put them all over plus or minus 2. So I'm going to say 2 over 2, which is just 1. 4 over 2 is just 2, so I've already listed that twice. 5 over 2, negative 5 over 2. 10 over 2 is 5. I've already included that. And then 20 over 2 is 10, which I've already included. So I just have to include these two as well. So we won't be using the rational zero theorem very often. Most of the unit and all of the homework, basically, except for maybe one question, will come from the stuff that we're learning using graphing. So if you want to find the rational zeros without having to list out all of the possible ones and guessing and checking, it's easier to just graph your equation, find all of the rational zeros. So we're going to graph it in our calculator. So I'm going to write calc next to it. Then find them all, so whole numbers or numbers that can be written as a fraction, not the imaginary ones because we don't know how to find those. Then we're going to use synthetic division to find the rest of them. We can either factor, remember that we want to get it down to a quadratic, so an x squared. An easy way to know how to get it from x squared, if it's already an x cubed, then I do synthetic division once. One time. If it's an x to the fourth, then I need to do synthetic division 2 times. If it's x to the fifth, then I need to do synthetic division 3 times. So you basically have to keep doing it until the degree becomes a quadratic. It becomes an x squared. So every time you do synthetic division, it's getting 1 degree less every single time. So we're going to look at this number 3. I'm going to show you how to graph it and then how to find the zeros on the calculator. I'm going to do that with you once, and then I'm just going to tell you what the zeros are. You can just do them on your own calculator afterwards. So we have x cubed minus 8x squared plus 11x plus 20. So I have the graph on the calculator. I've graphed it, and all you have to do is add graph, type in the equation. If I want to find my zeros, then I'm going to go to Menu, Trace, Graph Trace. So Menu 5, 1. Then you can scroll left or right. Here it pops up and it says 0. So I have a 0 at -1. You only really need to find 1, but you can keep going if you want. 4 and 5. So I can choose one of those and use synthetic division and then factor the other two. So I have -4, or I have a -1, a +4, +5. So it's gonna pop up with that little yellow tab that tells you what the 0 is, and that's where it crosses the x-intercept. So I know that my zeros, I know the first one is x minus 1. So x equals -1. So I'm going to use that, and I'm going to use synthetic division. So I'm going to do 1, -8, 11, 20. Bring the first one down to get 1. -1 times 1 is -1. -9, +9, 20, -20, 0. I rewrite this as x squared minus 9x plus 20. Two numbers that multiply to get 20 and add to get -9. That would be -4 and -5. So I can factor this to be x minus 4, x minus 5, set them equal to 0, and you get x equals 4 and x equals 5 when they equal 0. So then my 3 zeros would be -1, 4, and 5. And when I graphed it on the calculator, it actually showed me all 3. I just wanted to check my work using synthetic division. So here is number 4 graphed. X to the 4th minus 7x cubed plus 10x minus 24. So I'm going to go to Menu, Trace, Graph Trace. I'm going to scroll left and right. I have a 0 at a decimal. Can't have decimals. Another decimal. That's not good. Here's a whole number at 3 and a whole number at 4. So when I record them, I'm going to record the whole numbers, and then I'm going to get the other two as fractions. So we found, using graphing, that I have a zeros at x equals 3 and x equals 4. And I also had them at decimals, but I can't use synthetic division to divide those out. So I'm going to do synthetic division twice because it's an x to the fourth. If I want to go to x squared so I can factor, then I have to do synthetic division 2 times. So what that looks like, if I do it twice, I'm going to do 3 first. I'm going to write out my coefficients. So 1, -7, 10, 14, -24. And bring the first one down. 3 times 1 is 3. -4, -12, -2, -6, 8, 24, 0. Then I'm going to do it one more time, so don't record it yet. I'm going to draw another box and I'm going to put 4 here. Bring it down. 1, 4, 0. 4 times 0 is 0. Add, you get -2, -8, 0, check. So I've factored it twice, or I've divided twice. Then, since I've done synthetic division twice, here it became x cubed, here it becomes x squared. So I've done it twice. I'm going to write this as x squared. There's no x, so then this is a constant, minus 2. I'm going to set this equal to 0 because it's already factored for me. So I'm going to say that x squared minus 2 equals 0. X squared equals 2. So x equals, I'm going to square root each side, plus or minus the square root of 2. So I'm going to come over here. My final answer would be x equals 3, x equals 4, x equals negative square root of 2, x equals positive square root of 2. Just like that. For number 5, you can do 2 things. You can either graph it and then see that it has an x at 0, or you can also just know that each one of these 3 have an x in common. So if I pull out an x, then I'm left with x squared plus 5x plus 3. And so my whole goal in this is to try to get it down to an x squared, because once I get it to x squared, then once I get x squared, I can either factor or use the quadratic formula. So in this case, I don't have 2 numbers that multiply to get 3 and add to get 5. It's impossible, unfortunately. So we get to do the fun quadratic formula. So I'm going to write this as, if my a is 1, b is 5, and c is 3, x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. So x is equal to negative b plus or minus. I'm going to simplify. You get 25 minus 4 times 1 times 3 is 12 over 2. Negative 5, I'm rewriting it, plus or minus the square root. 25 minus 12 is 13 over 2. I cannot simplify this 13 anymore, so my final answer I leave as is. I cannot simplify it any further. I could divide it. I could say negative 5 over 2 plus or minus the square root of 13 over 2. So my final answer is going to have x equals 0, x equals negative 5 plus square root of 13 over 2, and negative 5 minus square root of 13 over 2. So that'll be my final answer. For number 6, if you look at the graph, you'll see that there are zeros at x equals 1 and -2. And it also touches 1 twice. So what that means is, like, if it touches 1, then that means that it has a multiple of 2. So that means that if it bounces off the graph, then I say that x equals 1 with a multiplicity of 2. So if I were factoring this, then it would look like x minus 1 squared x minus 2, and then something else. So this squared right here indicates that it has a multiplicity of 2. That means that it bounces off the graph. So if you look at the graph, it touches 1 and then it shoots right back up. It doesn't actually go through 1. Like, it touches it approaches 1. I don't know what the graph does, like this. It touches 1 and then it comes back up. So if it bounces off the graph, we're going to say that that's a multiplicity of 2. So that means that I can divide by 1 twice, which I'm going to show you here in a minute. So I can divide by 1 twice, and then I can divide by 2. So I'm going to use synthetic division. I'm going to have to divide, since this is x to the 5th, I'm going to need to do synthetic division 3 times in order to get down to x squared. So the first one is I'm going to divide by 1. I'm going to do synthetic division by 1. I have 1x to the 5th. I have 0, x to the 4th, 1x to the 3rd, 2, -12, and 8. I put a 0 here because there is no x to the 4th. There isn't 1, so I put a 0 there. If you forget the 0, then it's all messed up. 1 times 1 is 1, 1, 1, 2, 2, 4, 4, -8, -8, 0. Going to do synthetic division again. I'm going to use 1 again because it is 1 twice, because it bounces off the graph. 1 times 1 is 1, 2, 2, 4, 4, 8, 8, 0. And then I'm going to divide it one more time by -2, -2, 1, -2, 0, 0, 4, -8, 0, check. So now this is in terms of x squared, so it went from x to the 5th to x to the 4th to x to the 3rd to x squared. So it is like saying x squared, no x, plus 4, that equals 0. You end up getting imaginary numbers. So if I set that equal to 0, I say x squared equals -4, x equals the square root of -4 plus or minus the square root of -4. So x equals plus or minus I square root of 4, took out an I. X equals plus or minus the square root of 4 is 2i. So my final answer would be x equals 1, 1, -2, -2i, 2i. So for number 7, if you graph that, you should find on the graph, if you look for the 0, it says a 0 at -2/3. X equals -2/3. And so if I use synthetic division, I can actually use a fraction, -2/3. I'm going to write this as 3, -4, 8, x squared, 8, and 8. if I bring the first one down, I have 3. Negative 2/3 times 3 gives me negative 2. I add those, I get negative 6. Negative 6 times negative 2/3 gives me a positive 4 times 12. Then I have negative 24 over 3, which would give me negative 8, 0. So then I am left with 3x squared minus 6x plus 12. From the graph, you can only see that it just goes through the x-axis one time. The other two are going to be imaginary. So this would end up having 2 imaginary solutions. And so we're going to do more with that in 5.7. I just did in the last example, number 6, I kind of did a sneak preview of what imaginary will look like. But for now, I just want you to find the real ones. We're not doing imaginary. So the imaginary ones in number 6, you can kind of just disregard until next lesson. So if you were to graph number 8, you would see that it also only goes through the x-axis one time. It has a 0 at x equals 2. So if I were to use synthetic division, I would have 1, negative 4, 14, negative 20, and I'm going to bring this down. 1, 2, negative 2, negative 4, 10, 20, 0. So then I am left with x squared minus 2x plus 10. And then you would need to use the quadratic formula, but it's going to be imaginary, so we will do that in 5.7. So we have a lot to look forward to. So for now, we're just finding the real roots. So the only real root would be at x equals 2.